to the computer. What? Really bullying me. No, I'm not. Sorry, I interrupted earlier.
Keep an eye on time here. To go. Hey guys, can I take a minute? This is a warm-up question. Ask you write the equation of the line in slope-intercept form. You hear it off my screen here. Don't save.
Don't say. Ooh. Take that, Garrett. You burned.
Alright, so again, you should be able to write an equation of the line using the 2 points they give you. So they give us these 2 points. We're trying to find the equation of the line. Careful, mine wasn't showing the negative. That goes through those 2 points. So what did you guys get for your slope? Half. That's agree. If you didn't get half, makes the rest of the problem really tough because everything else depends on that. So we're going to do y2 minus y1. So 6 minus 1. And then 4 minus a negative 6. 5 over 10, which is 1/2. So getting that slope correct is so important because it's going to determine your y-intercept. So if that's wrong, the rest of it ends up being wrong as well. So careful with that. Okay, so once we know slope, then we can choose either of the 2 points to figure out your y-intercept. So half of 4 is 2. So we find out b is 4. Yeah, good luck. Alright, so now correlation is actually probably a word you've heard before. Well, first of all, you heard it in algebra, but you probably have heard it maybe in science class, a correlation between different values. It's how the values interact or the variables interact with one another. So how one causes the other to change. So it's a relationship between 2 variables. And so we're gonna talk about positive correlation, a negative correlation, and no correlation. So how those impact each other. So an example of positive correlation is if you guys have a job. What happens when you work more hours?
You get more money.
You get more money. But then if you're like, I don't really feel like going into work today, what happens to your paycheck? It goes down. So the more hours you work, the more you get paid. The less hours you work, the less you get paid. It's kind of one of those things, like, it's like, yeah, I want the night off, but I also want money. You know, your paycheck comes back and you're like, what happened there? So the hours you work, as those go up, the amount you pay goes up, or the amount you get paid. But it works the other way, that as the number of hours you work goes down, or if they don't need you as much, that would go down as well. So positive correlation is going uphill. Now, we kind of just do kind of random dots going uphill, because it all depends. There's people you work with that work the same amount as you and they get paid more. They have a higher position, or they've been there longer. So that line isn't always a perfectly straight line. Or maybe you have a friend that has just a better job and they work, not as many hours and get paid better. Now, obviously with hours, negative hours don't really happen, so we might not need the whole graph, but the idea is there. Then negative correlation is maybe let's talk about that job. The more hours you work, maybe you get less sleep. Maybe you have less time to do other things. So if you're working more, or maybe we'll even say working more, free time is less. So the more you work, the less free time you have. So this one goes downhill. As the number of hours go up, the amount of free time goes down. So negative correlation, again, is going downhill. Now, again, that might be kind of a staggered line depending on your other situations. Maybe you say, well, I play a sport as well, so my free time is already pretty limited as it is, or I have chores to do around the house, or whatever it happens to be. Maybe you just don't have much free time to job. And then no correlation is something that doesn't impact something else. The one I like to use is because everyone knows someone who does this, who watches a sporting event and watches like people scream at the screen. Does that impact their team? No. So me yelling at the Brewers right now is not going to help, them to win a game. Right now, they talk about there's really not a home field advantage anywhere for any sports because there's no fans there, because fans actually do help if they're in person. So cheering from home. So tonight you want to watch the volleyball game at home. Although it's nice you're cheering at home, it is not impacting the outcome of the game. So if a ton of people are watching online tonight, cheering for our volleyball team to success, that doesn't really matter. The outcome of the game it could be all over the place. There's no correlation there. Now, obviously, we know some outliers. We know teams that win all the time. It doesn't matter if they have fans or not, or that lose all the time. It doesn't matter if they have fans or not. But again, the cheering at home does not impact that at all. Okay? So positive, no correlation, or negative correlation. And again, I know you guys have talked about this before because part of it is, if you had me for algebra, I taught it to you. So you definitely have learned it at some point. So a little bit of review here. So it says this graph has weightlifting. Across the bottom has weight in pounds, and up the side it's repetitions. So is this a positive, negative, and no correlation? So as the weight goes up, what happens to repetitions? Goes down. Why is that? More weight, it's harder to lift, so I can't lift it again and again and again. But if it's less weight, you might see someone like, I can do 100 reps of this. Well, that's not, not very tough, it's not much weight. So this would be a negative correlation, because as the weight goes up, it's harder to lift the weight, so you can do less. So how many you can do goes down. All right, so we're going to talk about how to draw a line of best fit. And if you haven't gathered right, this is the lesson that goes with Barbie Bungee. I think we'll have time to do her today, but we'll see. Otherwise, we could always do that next time, but I think we'll be okay next time. And we could probably do that outside. We can probably use the tree or something, or side of the building.
Or to the future buffer.
Well, we're gonna do the bleachers, but we don't want to do that yet today.
Let's go on the playground.
So,
That's a different day.
yeah.
No.
Barbie Bungee.
Oh.
Did we never do that this year?
Oh my God. No, we didn't do it.
Yeah.
I still have videos on my phone.
Yeah, me too. So, to find the line of best fit, and the reason we do Barbie Bungee is to make a prediction about what Barbie can do, and we'll talk about that in a little bit. The line of best fit, we're gonna start by plotting the points, and actually, yeah, that's fine, we can do this one. I was gonna say let's to the other one, but that's fine. So you're gonna start by plotting the points. So you're gonna plot the points, so like -5, 9, I'm gonna plot on my graph. Put all these on my graph. So I drew my graph there. Now what I want to do a line of best fit is I want to draw lines as close as I can through the data. So trying to get point of my line to go right through the data. I'm going to show you first an example of a bad line of best fit. So this is what not to do. So don't follow this one. This would be a bad example. Why is that a bad line of best fit? It connects two dots. Yeah, Ethan?
Ignores the vast majority of dots.
Yeah, it kind of like just overlooks all these dots down here. That's not really the trend line. That's not really what's happening to the data. So what we want to do is try to fit the line to go through as many points as possible, kind of like right through the middle as best we can. Get it to move. So sometimes on my board, I can kind of play around with it. You might not be able to. So I try to fit my line through as many points as I can. That's looking much better. So my line of best fit isn't just like kind of haphazard or random. I'm trying to fit it through as many data points as I can. So we're drawing that line through the data. Now I'm ready to write my line of best fit equation. And this is really what we did in the warm-up question. We're going to take 2 points, or what we did in like question 29 up here. We're going to pick 2 points and that are close to our line. So again, I would not want to pick the top 2. These would be a bad example of points to use. I don't want to use those 2 because remember that line wasn't a very like good line of best fit. I want to pick other points that are close to my line. Pick 2 points, and we're going to figure out the slope, the y-intercept, and then our y equals mx plus b. So how about like the third point and the last point? Do those look good? So it'd be like this one and this one. Those look okay. Okay. So now, had you picked two other points, again, long as you're not picking like line points that would make a line that doesn't go through our data, your slope and y-intercept is going to be close to ours. It might not be exact. This is one time when our homework could maybe be different from one another. So we're going to subtract these two. So we're using this. So I'm going to do 6 minus 0 over negative 2 minus 2. So 6 over negative 4. So negative 3/2. Does it make sense that our slope is negative? Yes, it's a downhill graph. Nice negative. So our slope we found out is negative 3/2. And other years I've done this, I had that as well last year. I don't know if anyone tried any other points. As long as you're somewhat close to that, you're doing fine. Now the y-intercept, so we kind of already know that.
Yes.
Do you guys see it? It's going right through the y-axis. So I can see the y-intercept is 0, 3. Now, I could actually put some values in to check that. Like I could use 2, 0. I'm gonna find out it's 3 still. So I have my equation now, I'm ready to write. So y equals mx plus b, there's our equation. All right. So what we're going to do, we'll talk about the problem on the backside a little bit later. Actually, maybe let's get that done and then we can kind of do our project outside or go outside with Barbie. Okay? So let's do the next example and then I can upload the video for those people who aren't.
Come on, Barbie, let's go outside.
Okay. So the graph below is talking about weight loss per week of a diet. First of all, by the way, not saying anything about anyone's weight, what your weight should be, whatever you, so just heads up, I'm not trying to make you think you need to lose weight. So that's my disclaimer here. So, but you hear a lot about like weight loss stories. And actually, a bunch of my friends have been getting texts on their phone that say like, I will help you lose 70 pounds in 4 weeks. If, like, as any of your, like, so a bunch of my friends have gotten that. And like most people like don't need to lose 70 pounds. Like if I lost 70 pounds, I would no longer be upright. Like, I mean, there's, you know, you don't need to lose 70 pounds, most people anyway. So it's kind of, I mean, so understand that weight loss is individual things. So that's my disclaimer, not telling anybody anything right now. So be who you are, yes. All right, but this person's trying to lose weight. Dieter A. So in the graph, the Y represents the person's weight in pounds, and then X is the weeks of the diet. They want us to find an equation of a line of best fit for this data. So again, we're going to draw a line in there. And when I do that, again, I want to be smart about it. Like I don't know if there's really a bad line in this case. I guess I would say that's a kind of a bad line. It's too low. So I try to have it be more gradual than that. Don't move the graph. That's pretty good. It's hitting a lot of points there. Kind of draw a straight line through the data. And we're going to pick a couple points that look good to use. Right away, the point at 5 weeks jumps out at me. Because it's a nice whole number. 5, 170. Any other point you guys think looks good? 3, 175? Sure, let's use that. So after 3 weeks, they weighed 175. After 5 weeks, they weighed 170. So losing weight, it's going down. We want to find the equation of the line the best fit. So we again have to find the slope. So y2 minus y1 over x2 minus x1. So 5 over negative 2. We need to now find the b. So we're going to put this information with our slope to find our b. So which point do you want to use? 170?
Yeah.
Okay. 170 equals negative 5 halves times 5 plus b. Now some of you guys might be mad at us for not choosing b to begin with. So if you're like, well, there's b on there. So this is a negative 25 over 2, which is negative 12.5. I'm going to add that to both sides. So in this case, our b is 182.5. So there's our equation of our line of best fit. So why this is good and why we're going to do this for our Barbie project that we're going to do in a second here is you can use the equation to make a prediction about the dieter's weight after 10 weeks. So if this continues, after 10 weeks, how much would the dieter weigh? How would you figure that out? How would I figure out how much they weigh after 10 weeks? What do you think, Matt? Yeah, this is our x. So we're going out here and saying, what happens at 10 weeks? We're going to put 10 in for x to our equation and figure out their weight. And 10 times negative 5 halves is a negative, was that 25? 50, yeah. So what will they end up weighing? $157. 157.5 pounds. Now the question is, maybe it's because we're talking about Barbie today too. Could this pattern continue for a year? And then explain. Could this keep going for a whole year? How many weeks are in a year? 52 weeks. Could they keep losing weight every week for 52 weeks? What's going to happen? It's going to be like the text I get that says I need to lose 70 pounds in the next 2 months. Like it's just not possible for this person to keep losing weight. How much are they losing each week? You guys see it? They're losing how much each week? 2.5 pounds. So for 52 weeks, that's going to be well over 100 pounds. And unless there's some sort of really tiny person, I mean, someone who started at 180 shouldn't probably be losing 100 pounds. I'm assuming. There's not many people that should weigh like, yeah, there's just not. Yeah, so they'd be way too small. So there's a limit to this. So obviously patterns like this don't continue forever. And obviously we want people to stay safe and happy. So there again, this is my disclaimer about, So understanding though, we can make a prediction. So sorry guys at home, we are gonna go outside.
Go to the bathroom.
But I'm gonna upload notes for you guys already. We're probably not gonna get to this example. Homework is listed here with your graphs.
Hi guys. Only 4?